afternoon, everyone. We'll get started. Welcome again to today's event. Our next speaker is Tim Crothers. He'll be speaking on, seriously, you expect me to believe Cyber-Spies want my data. Really? Really?
All right. Thank you.
Yeah.
So this is not a vendor talk. I do work for Mandiant. However, this is not Mandiant endorsed talk. The only reason I used a Mandiant slide is because, in case you noticed, we did sponsor. The reason why we sponsored B-Sides is we're hiring. So if you are looking for a job in the information security, specifically incident response and investigation, then go to our website. If you can't find where the job postings are, I don't want you anyway. So it is what it is, right? So that's the end of the Mandiant stuff. Like I said, this is not endorsed by Mandiant. This is my my talk, etc. Right? So I'm assuming if you're here, you've probably heard something about China or somebody. This is not a talk that says China is evil, China is, after all of our stuff. Every hacking problem is not China. However, China is definitely doing some interesting things. Now, I don't know, I just had up, for those of you who didn't bother to read the New York Times this morning, it was disclosed this morning, there's a 5-page article basically outing the fact that Stuxnet was written by the United States. Okay? Now, those of us who have classifications and stuff have known this for a while, but now it's public, so we can talk about it. The reason I mention this is because this is kind of the crux of my talk, right? I'm going to focus on some technical stuff here, show you some real logs, some real activity by folks that are doing this on a day-to-day basis. But there's really a second point to my talk today, and that's specifically that if you as an information security professional think security equals stand up a firewall, run IDS, look at some logs and run the antivirus, you need to go choose a new profession, okay? Because think about the ramifications of this, right? So the fact that Stuxnet has been unequivocally outed, right? And who here doesn't think that Flame was us, okay? I don't know that one for a fact, but sure seems awful suspicious, right? The bottom line here is that what? When Stuxnet hit, we had what? Some code errors in Stuxnet that caused it to spread outside of what it was supposed to. So if we now have it absolutely being declared, and the UN just announced some interesting things, which I haven't had a chance to dig into yet. Baitlik just tweeted, sounds like there's some really potential interesting ramifications of Flame that are flying right now. We'll all get to read about this evening. But bottom line is, if you don't think that other countries are going to jump on this, even if it's only China, Russia, the US, right, what have you, if you don't think this sort of information is going to induce every other country to jump on board, you're crazy, right? And so what's inevitably going to happen is we're going to get a bunch of people, and they're not going to be targeting your company, but what's going to happen is there's going to be some crappy code, and it's going to get loose outside of the target that it was made for, and you as an information security professional at mom and pop business are going to have to be dealing with the fallout from this. Our world is progressing and changing, and so we as information security professionals have to be keeping tabs on this kind of stuff. And that's really the subtext of what I want to talk about today. So when I say that, when I tell somebody that my day job is chasing Chinese spies, let me first put out there, if you had told me that's what I was going to be doing 5 years ago, I'd have first laughed in your face and then two, told you were smoking something, okay? I mean, I really do get how crazy this sounds, okay? And inevitably, people ask me, have two questions, right? One, why in the world would country X want my data? All right? I'm going to come back to that question. Secondly, if they're doing it, then why am I not seeing it? That's the focus of today, although I will come back to the first question as well. So the reason why we're not seeing it, or you're probably not seeing it, is not because it's not happening, but because you just simply aren't looking in the right places and don't understand necessarily what to look for. Hopefully I'll help a little bit with that, because where we're at kind of right now as an industry is there's a relatively small handful of information security folks that are kind of in the know, right? That understand how this stuff works, right? And know what to look for. Those guys are having good luck combating this stuff. Unfortunately, the other 98+% of us who are doing this aren't privy to that yet, and that's what I'm hoping to help a little bit with today, okay? So if we think about traditional C2, so command and control, right, malware, your botnet, that sort of thing, the way it works, right, is it's typically encrypted. It's using lots of times non-standard ports, right? If you think about a lot of the malware and the botnets that are going, it's relatively easy for us to pick out. Why? Because it doesn't look like normal traffic. So the bad guys, and this is not just the state guys, by the way, also the really high-end cybercrime guys use the same techniques, the same core techniques. And the bottom line is blend in with the traffic. And I'll show you how that looks here, right? So the first generation of command and control that we've observed for these guys, and by the way, all of the logs and the stuff that I'm going to show you are real. I have anonymized them to protect the not-so-innocent. They are not Mandiant clients. Everybody needs a hobby. Mine is, infiltrating command and control infrastructure in nation states. Go figure. So these are real incidents against real, but, again, I just want a couple disclaimers there. So most of this traffic, especially this first generation of command and control we saw, was all done via web, especially SSL, right? So again, let's dispense with the hype, and let's look at some of this stuff. All right? So here's an example of reach out by a box that's got a malicious backdoor on it to a command and control server, right? So what we've got, hopefully that's large enough for folks to read there. So what we've got here is this get, and again I changed the URL, but same type of thing, right? Get www.realmsnbcnews.com/iisstart.htm. What's iisstart.htm? Default IIS page for Windows Server 2003. So you stand up a 2003 box, you run, install IIS on it, and until you put content on that server, the default page is iisstart.htm. You go look at your proxy logs, you are going to see a lot of potential activity to IIS legitimate, even sometimes, right? Then we've got this, but look at this. Does this look like a user agent you've ever seen? Start filing away some of these sorts of things. But how many of you are mining in your detection systems looking for user agents? Detecting malicious activity? Anybody? I know a few people are. Probably can't say. All right, so let's go down here a little bit farther. And you notice it's a pretty plain looking page. As a matter of fact, if I go over here, I took that page and let's just bring it up in a browser. So there we go. So that's what the page looks like in my browser. Straightforward. But look a little closer on that page. Does anybody tell me what this is? What's that, bracket dash dash indicate in an HTML file? Comment, right? What does that look like to you? Anybody? Base 64. So let's pop open a little command prompt here. Run us some Python. Import. The joys of doing live demos, base 64. So let's print base64.b64 decode, and then copy this out. Whoops. If I can click, Control C. That base64 decodes as continue. Right? What you're looking at is an honest-to-goodness command and control server and an infected, a botted host, with a backdoor reaching out to that stage 1 command and control server. And the reason why you're not detecting that is simple, right? They're relying on the fact that you're a very busy network guy, security person. You've got all of these snort signatures loaded, so that's going to, you're using the bleeding edge, right? Not going to detect it, right? Anybody can go get snort. Anybody can go stand this stuff up and see what signatures are going to be detected. All right? Everybody with me so far? By the way, if you've got questions as we're going, don't hesitate. Is Patrick here? No Patrick? Oh, man. My designated heckler isn't here. It's all good. Let's look at another one. So here's another example, right? This is a different backdoor family, right, that our bad guys are using. So again, this is going out to, in this case, again, I anonymized it, but it was a similar type of thing, challengerelementary.org. Because again, the folks that are trying to infiltrate your network absolutely get that you use tools like WebSense that have lists of acceptable places to go and not to go, right? And so the real packet that I anonymized this from, right, was actually for a legitimate school. And there was an image that they're calling. But notice that we've got some inconsistencies here, right? So globe.jpg, and then look at the header down here. We've got GIF89, right? And actually, if you do some checking on that user agent looks close, but it's not actually a legitimate user agent, again, right? And what's happening here is this is, again, a stage 1 command and control, and I'll explain that in a second. This is an IP address that's embedded in this fake image sitting on a legitimate server that's going to go out your WebSense. Backdoor pulls this, decodes this IP address, and reaches out to the stage 2 command and control. Okay? Does anybody have any snort signatures that are going to trigger on this? Besides those groups in the know? No, right? Because this isn't in our normal stuff. It's not that we can't write signatures for this. You just have to know to look for it, right? So that's part of the trick, all right? So I'll keep going unless anybody throws out some questions here. So those are some examples of command and control activity. Now, the bad guys, though, aren't content to rest. And interestingly enough, and I unfortunately, just because we only have an hour today, right? So I can't give you years worth of learning on some of these particular groups in an hour, right? It's just not possible. But China in particular, who's one of the front runners on this, and I know I'm not proving that yet, that's all fine, and it doesn't have anything to do with Chinese IP addresses, I promise. But the bottom line is they're doing classes now for other countries. And the reason why they're doing those classes is because they've gone on to a new level of capability, so it's earning them brownie points, so to speak, by teaching, say, Russia and some of the, and it is a lot of countries besides just China. Okay, China just happens to be the most prolific at the moment. And so they've revamped this. So now a newer trend that we've seen, especially over the last 6 months, which is kind of cool, is they've taken a lot of this off-the-shelf software, web shells, right? Web shells have been around for years, right? Forever. And if you don't understand what a web shell is, basically the concept behind a web shell is you take the web shell's code, drop it on a server, and then you connect to the web shell running on the legitimate server. Typically, it's a server on your edge, right? So it's got internet facing, and then you use that to pivot into the environment, right? Web shells have been around forever. But you start to combine some web shell technology with mini-port drivers, and you got some cool stuff. So a mini-port driver is kind of a stub driver. And the way a mini-port driver works is it tells the operating system, I want this type of activity. And it allows, literally, you to run and look for data on a port that is otherwise bound to a different application. So in this case, you run a mini-port driver that binds to port 80 and 443. The mini-port driver is getting that before shunting it over, and lots of times they can cause this stuff to not even bother showing up in your logs. Right?
Tim?
Sir?
So is the original process and the mini-port driver both bound in the way that we think of the old way of binding, or one is and the other one shimmed in? Or?
It's loaded in a normal starting with Windows Server 2003, Microsoft provided support for mini-port drivers. If you go look at if you pull up a typical Windows box, say like Windows 7, you will typically see, say you're running VMware. VMware uses mini-port drivers to hook the physical driver for your virtual machines. Most VPN clients use mini-port drivers to hook the NIC for the virtual. They're using that technology.
So if you did let's say the machine was not rootkitted, so
Yes.
you would actually
Yes.
give you the correct response, and if you did a netstat, what
Yep.
would show as listening on port 80?
Show as listening on port 80 would just be the web server, typically.
Okay, so the mini-port driver just says, hey, I know somebody's already bound to this port, can you just also shimmy in and give me all the data?
Yes, that's right. And then it can pull out the data that it wants and literally not pass it on to, if it so desires. And usually they're not even bothering with rootkits because we're not looking for this stuff. Because we're all still, and I include myself in this, right? It's easy for us to fall into these mentalities where I understand the bad guy, right? He's some, buddy that's works out of his mother's basement, that old hacker image. And the world is continuing to move, right? And that's what we've got to keep track of. We can't assume that it's the same thing over and over. Now, I've actually got a demo on this I can do, but I didn't fire it up today just because I realized that we're probably not going to have enough time. But if we have some time, I'll pop back to that. So I've installed this on a Windows 2003 virtual machine and can demo that. But the beauty of this stuff is again, that simply it just works with our existing environments, and we're so inured to looking for it, right, because we don't know, that we just pass this stuff right over, right? So let's talk about our existing detection a little bit. So here is a snort alert, and you'll notice I put in red here some garbage. Can anybody tell me what that is? Unicode. Because Snort and most of our tools here in the United States work on ASCII. The rest of the planet does not work on ASCII, literally. But again, we've not been progressive enough, we as an industry, to keep pushing the fact that we've got to be looking at. Look what happens when I take that exact same alert, right? So let me pop that guy up. So here's the original, here's the alert, right? Oops, let me pull up actually. Here's the original that I had, right? So XP command shell attempt. So you're the security guy, right? You look at this. And this looks like some SQL, but you don't actually see anything overly concerning looking in there, right? We can scroll through. And again, this comes from a real situation. So they were looking through, and it doesn't. So here's the XP command shell, but in this case, the organization that had this alert triggered passed this off as they thought it was one of their legitimate SQL applications that was communicating, right? And indeed, and part of it, right? We're all got 15,000 things on our plate. So again, right? So looks like garbage. But now I pop that same. So this is an ASCII editor. But now I go over here to a Unicode text editor. If I can click, there it goes. This is just a free one. And I pop that same thing open. And now look what I've got. Same exact alert. If you're the security person, you see it the second way versus the first way. Are you going to be a little more concerned? You're an English company and you're seeing non-English characters going to and from your servers. China or whoever aside, that's going to raise some flags to you, right? So that's purely a tool issue, right? That we're not seeing that. Let me get to the right one here. Everybody still with me? Oh, there it goes. All right. So same alert, but now in Unicode. Obviously, it looks a little more concerning. Okay. So we see them use a lot of publicly available stuff. So, of course, why in the world use publicly available stuff? Poison ivy is hands down the most popular rat that they use, remote access Trojan. Why in the world would they use poison ivy?
It works.
It works, right? Source code's available, so that all they got to do is maybe modify it a little bit so it doesn't trip AV, right? Because that's pretty straightforward. And these are a bunch of tools that we've observed. AXPS-Spy is one of those simple tools for, it's a web shell, right? Cache dump, get hashes, Ghost Rat. Ghost Rat, we're seeing they've recompiled and are using against Macs. Because, again, source code's readily available. GSEC dump, dumps credentials. We're going to see some of this in a minute. Hook MSGina, HTRAN is a tool for passing a lot of this data out. Right? So publicly accessible tools, right? They already exist. And in a lot of cases, we're using them. Right? We use PWDump. Who here has not legitimately used PWDump for some sort of security audit or other purposes in your environment? Almost all of us are going to have, right? Because PWDump is an incredibly useful tool, right? For if you want to check what the passwords look like, etc. So we'll see these tools pop up, but because we recognize them as commodity malware, we don't stop to go further and think about who might actually be using it. It's much easier for pass off because if I'm thinking a nation state wants me, then what's my first thought, right? So I'm going to movies, etc. I'm thinking, oh, they got some cool, sexy stuff. Why? Why use cool, sexy stuff when the stuff we all have access? And here's the beauty part, from my opinion, is because this stuff is all readily available, we can easily build signatures for it, right? So you can go out later, pull these tools, and create your own signatures to start looking for a lot of this stuff. But I'd be willing to bet most of your tools don't have detections right now for that. Or if they do, you tend to pass them off, right? So let's look at a log, because it's always cooler to look at a log. So let me just preface this a second. So I mentioned earlier, stage 1, stage 2, command and control. So the way this works is most common way that they do this is spear phishing, right? So what will happen is you guys will do like a press release, And I'll talk about some of the reasons why you might get targeted in a bit. But there's lots of readily available contact information on your organization, right? You realize that. Email addresses are really easy to come by. So starts with the spearfish. User clicks on the spearfish, installs the backdoor. That's what we refer to as a stage 1 backdoor. And basically what that stage 1 backdoor does is goes out to a stage 1 server, which essentially you think of as a parking server, right? So based upon the particular version, and they'll have compiled it fresh, right, for you, for that particular run against you, so it doesn't trip AB and stuff like that, right? So it doesn't have a known bad MD5. These are simple to avoid, right? It'll go out, might be a 6-day interval, might be a month-long interval, you know, could be every 5 minutes. Whatever interval it goes out to this stage 1 command and control. Now when the bad guy's ready to activate this, right, what they do is they just change that. Notice how that example I had continue? They change that command. So now it goes out and retrieves that IIS start.htm or whatever particular. That's one of many techniques, right? But that in that example, to point to an IP address where they download the stage 2 backdoor and begin live interaction. And you'll see why I'm confident this is live in just a second. So the way I come up with this log file that I'm about to show you is pretty straightforward. So that same IIS start.htm that's sitting out there, right? Once you know where those are, you can go pull it too. There's no magic in this, right? You pull that, you decode, and now they are often a little more complicated than coding. But if you figure out you've got a host here, what you want to do is do some simple reversing on that backdoor. That'll help you figure out what that encoding is. So now you can decode this if it's a little more complicated than, say, the base 64, although lots of times it isn't any more complicated than that. And then they activate it, now you pull. So that's what I do, right? And so you just pull this just like they do. And so when the bad guy in this particular example, he has this little tool that pops up, right, that he runs on his screen. He types the command that he wants to run into it, hits enter. What it does is it encodes it and writes that updated file out here. This backdoor is just pulling it, running the command, sending the results back, which he is then retrieving. Everybody with me so far? Pretty straightforward process. It's really not that complicated. And what we end up with is a log like this. Okay? So what this is I left the timestamps in, and I did anonymize because, again, this was against a real organization, and I don't really want to out in case they haven't been in the news, although I know they know about it in this particular case. So we've got a whole bunch of commands here, so let's spend a little bit of time looking on this, because you also want to really understand how they move around, because in most cases, it's not how you've been told. You know, if you've taken, you're a certified ethical hacker or something like that, that is not how these guys work, okay? They're not running Nmap. They don't need to, as you'll see in a second. So first thing they're doing is they're getting in and they're doing a task list find data. Well, that's actually them looking to see if their backdoor is running. Okay? And then they do a task list V and they quit and then they come back. Now, in this particular case, I had some context on what was going on in this one, right? The user got, clicked literally shortly before that 1038. Because I happened to be monitoring the stage 1 command and control in this particular instance when the user first checked in. I saw the new check-in, right? And then they immediately moved. So these timelines give us actually a pretty good representation of what's going on. So the first thing they do is they download, this is their backdoor. This D: command is a command inside the backdoor to download. So that's just simply saying download from XXX, the actual IP address, right? /tool/nwsapagent.dll into the temp directory. So that XXXX, in this case, was a university computer. Okay? So again, it's going to be WebSense. This download is just an HTTP download. You know, kind of like you'd do if you did a wget, right, from a Linux command line. And then they run cmd.exe, and they start looking around. They're doing directory. Then they download RAR, good old WinRAR. They need their RAR tools. Then gsec_dump, that's a tool for dumping out credentials. pwdump, okay, good old pwdump, same pwdump you use. bb.dll, backdoor. NetView is pretty much what its name implies. They run NetView. It shows the network connections from that host. Okay, and you'll see why in just a second. PSLL, process lister. Okay, so then they go down. First thing he does is runs NetView. So we're on patient 0 here, right? Host 0 that's just been popped. They clicked on a spearfish, ran the back door. Oh, bad guy wants in there. Runs a NetView. Think about your PCs, right? Maybe you don't run Windows, but most environments, right? You run Windows box. You've got network drives mapped. You've got connections out to different systems, right? So that shows that. Then they extract out pwdump. Then they run 3 commands that map out the entire network. netgroup domain computers / domain. So that lists from Active Directory all of the computers in the domain. That's a list of all the computers. Try these commands when you get back if you don't believe me. netgroup domain users / domain. So now we have a list of all the computers, and now we have a list of all the users. netgroup domain controller / domain. Who needs Nmap? Right? Think about the fact that in your environment, Active Directory already knows everything about your environment, whether you realize it or not. So in 3 commands, they just mapped the entire network. And we're what? Exploit plus 14 minutes? In. So are your detection and response mechanisms going to be catching this in 14 minutes? Maybe. Then they run a pwdump localhost, right? So if you've run pwdump, then you know what that does is dumps the local cache. Okay? In the local cache are the passwords, usernames, and hashes that have been used, right? So of course they run this through rainbow tables or whatever, because right, because they're going to see these list out, right? Here they type them so they can see. And sure enough, they've got user Bob. I did change the name of the user. It wasn't actually Bob. Again, I didn't want to. Then they stopped the antivirus. You know, that's pesky antivirus. Yes?
Question. You were talking about them possibly using a rainbow table, but according to those timestamps, you're talking less than 2 minutes later, they're logging in as Bob.
Yep.
But the rainbow tables aren't being run on this machine.
That's right. They're running on their computer, right? You've got the rainbow table. So remember the content. So bad guy sitting here typing this, when he typed type 127, that caused that list that he dumped to come up on his screen at his computer. Boom, you run those through. And remember, you don't have to have the massive rainbow table. You can have a small one. So all he needs one to start with. Okay?
Because the password also is a dictionary word, all lowercase, it would probably be more efficient to
And
on it first.
Maybe, but think about what they're trying to do. They want to avoid detection.
No,
And
I mean like a John the Ripper local report.
oh yes, yeah. They don't want to run that local though, because that's you're going. You know, as a security professional, that if you're worth a bag of beans, you've installed detection to pick up brute forcing.
What I meant to say is, because it can take some time to get looked through the rainbow table.
Yep.
A lot of times you'll see really simple passwords.
Oh, sure. That's true. Yeah, I don't know for a fact that they ran rainbow tables. Yes. Could have just run John the Ripper, could have run, whatever tool. But the bottom line is, we know for a fact that here at 10:55, they were successfully logging in. That's the bottom line. And what he's then doing here is He downloads the backdoor, which he downloaded earlier, if you'll recall. He's busy. He forgot. He got distracted. Then he starts doing a net use. So I renamed the computer names so they're sequential, but they all had the -XP, right? And we do that in our environment, right? And what does that for? So it's easier to administer with our naming conventions. Or what other common things we do in our environments? We name them based on geographical office locations, and not to say don't do those. You just want to be cognizant as a security professional, right, that helps you and them. That's all, right? The thing is, they got a list of computers anyway, so really it doesn't matter, because when those lists come up, and what are they using for this user? They're using user Bob T. So here what we did, what happens is PC 1, 2, and 3, where were those PCs? Those were in the net view. So essentially what just happened here, dropped onto PC 0, net view, who is it connected to? Pull the local usernames and hashes. What are the chances one of those is going to work on one of those computers you're using? Right? And then we move to PC 2, and we do it again. PW dump, rinse and repeat. Right? So what happens is drops on, runs. But remember now, from a detection standpoint, he's using legitimate user credentials. PC002, right? PC001, 003, that was a legitimate login. No brute forcing, no illegitimate login attempts. Pull it from local cache, use it to the computers that they're connected to, rinse and repeat. So we start down. So here he installs his backdoor, sets up the NWPS agent, makes sure he's got his parameters, and then he starts it up. So he's got backdoor and a couple, runs a process lister, makes sure everything's going, PW dump against PC14, right? Rinse and repeat. Then we get down here, and now he wants to know a list of the members from domain admins, because that might be useful accounts to target. He's pulling his tools down on some additional boxes. And then here at 12:22, so we came in at 10:38, now we're at 12:22, PC6, I named these sequentially. So by the time he's hit the 6th box, which is under 2 hours, we're about 15 minutes shy of 2 hours into this attack. He's got what? Somebody knows what this is, right? EPO admin. What is that in the environment? It's a local admin baked into all of our images on all of our machines so that we can push antivirus updates. Is there some irony there? Right? So he's using that local admin account, and from here on out he uses that. And in particular, look where he goes for number 7. -DC. Gee, I wonder what that is. Domain controller. So now we're still 7 minutes shy of 2 hours from initial click on the spearfish, and this individual, whoever it may be, right, has a list of all computers, has dumped the entire Active Directory domain, has all users and passwords. So I'm not saying this is FUD. This is a real live log, right? I have thousands of these. I am not kidding. Thousands, right? And it's simple process. This is not advanced stuff. And actually, it's a playbook, right? It's literally, these guys do this same thing over and over and over. I'd be willing to bet these are the junior dudes, right, that are assigned to this. Did you have a question, sir?
Yeah, the interesting thing for me is that they don't rename any of the standard tools. So so it's interesting to me that they don't rename any of the standard tools. So for example, you could do software restrictions on something like PW dump.
Sure.
It might slow them down.
It would slow them down.
But
However,
ultimately-
remember, this is a live person behind. Notice how he kept doing task lists and stuff like that? You do see them hitting environments where they've done that, and they'll see what you've done, and then they'll change it.
So they'll
right?
go look at
when they
group policy?
download, right? See this download? Notice when they download it, they give it a name locally. That not necessarily, it doesn't have to be the same name as remote, and you'll see
Right.
this a little bit, right? It's a good thought. The key, though, there, I like where you're going in that this is the important thing is to understand the methodology, because this is not magic, right?
No.
It isn't. This is absolutely detectable. You just have to know to look for it, right? And the key thing here I wanted to stress at this point is, again, we are sub 2 hours in. And most environments that, and I get to work with lots of organizations with some really, great reputations, and I really challenge you to think about, will your detection and response mechanisms, right, allow you to catch and respond to this breach in 2 hours? If you can, you're among a rare few. Now, how are we doing on time here?
So are those also, like, is that really in the middle of the day? Or
Is that what?
those timestamps are like wanting to,
Yes.
work hours?
These are 23 hours. That's right. This is during the middle of the day. So again, that's why, right? So this is legitimate user activity. Well, except that a user shouldn't be running pwdump. But what do we do when we set up that local admin because it's the Mac? Because nobody's going to find that, right? We turn off logging on it because it's too noisy in our log. We do all of these things, and the bad guys just simply are using those against us, right? That's why we're not seeing it. Lots of interesting things in here. In interest of time, I'm not going to, belabor all of this, but they do a lot of just really unusual, like ping-n1, right? Which is, when I type ping, I type ping, On Linux, that pings until I hit, Control-C. On Windows, it's 4 pings, right? I can't not see this without thinking about, Hunt for Red October. 1 ping only, right? And it's little things like this that lead you to conclude that they're running this from a playbook, right? So we've got more activity here. Again, now notice they're really abusing this EPO admin. Again, they're doing some more stuff here with backdoors. Anything else notable there? Nope. So let me jump down here. A couple other things I want to show. Now this is a run earlier on that same day against another host. And they use a couple different tools here, which is why I wanted to point this one out. One is this NTT, and the other is MAPI. So the first thing to do is this NTT. NTT is pass the hash tool. So obviously they wanted to use whatever this user, but they didn't crack it for whatever reason. So okay, we gotta escalate and use our pass the hash tool. And then this MAPI is a really cool tool for extracting email. So here what we're doing is they run this MAPI against this Exchange server. They're pulling this user's email for this date. Why they're targeting that user that date, I don't know. But they were. So they extract that, and then they go down here and they RAR it up, right? And the reason we're pretty confident that they love RARs is because, especially for big transfers, if you detect a RAR transmission in progress and cut it off, the RAR data, whatever was in that even partial RAR, can still be extracted. Whereas if you've got, say, a zip file and you break it in the middle, say you see exfil going on, exfiltration going on, you cut it off, they're screwed. They can't get the data out of a partial zip. It's got to be complete for the extraction to work, right? What they're doing here, -HP means to encrypt it and to encrypt the file names. And here's their password. It's what we call a finger walk. 1, 2, 3, bang at pound. They love to use the finger walk passwords. And
kind of ironic
Well, but again, we'll see, but look what they're doing, right? So now they move it out, so there goes the email, right? And this task list, so HTT actually runs in the background. That's why they're doing this task list, okay? And then once done, they clean up after themselves, okay? So here, they go to add somebody to check the administrators group. See why I'm confident this is not an automated attack, right? And we'll see some more of this in a minute. Then they're pulling a tool down here for attacking SQL servers. So this is a brute force tool, and what this is doing is it's trying to break into this list of, this is a text file with a list of SQL servers. This is the account name that they're trying to use, SA, right, which is the system administrator password for MS SQL, with this text file of passwords. And sure enough, they get in, SQL add, they install a backdoor. Notice what they set for the backdoor password. Again, the finger walk passwords, right? And they do some more stuff with that. Again, I won't, in interest of time, go into all of that. Because again, this is rinsing and repeating. Here's another tool that they have for retrieving email. There's some more activity. I'm just looking for the high points here. Yeah, nothing hugely interesting. So now we get into some serious exfil. So this is actually a different organization. And again, I changed the names of the directories here, but the directory names that they were using were very similar. And I would ask you to think about the documents that you store on your computer. The naming conventions that you use to organize do what? Explain, in most cases, exactly what that data is. That's how they find it. It's as simple as that. dir, right? And so here, again, we've got, you can't spell information, right? And so then he goes, oh, well, I needed quotes. Nope, that didn't work. And then he realized he had misspelled it, but when he corrected it, he misspelled it in another place, right? And so then he goes, all right, I got to look at that. So he backs up a directory. Then he realizes the right name. He progresses down. And sure enough, he eventually finds the documents that he's looking for. Okay? And the document names are often all you need, right? I can tell you that there have been at least one instance where looking at these logs at 2 a.m. in the morning, I've called, because what I and other folks have done is pass these logs to the FBI, to the Bureau, so they can go notify these poor folks. But the bottom line here, right, is that this data really tells the story lots of times all by itself. So again, they rar it all up. So this is a download here, slightly different variation. This WinSVR is just WinRAR renamed, rar.exe. Notice that they're raring it up as a WMV file. It's a RAR file. They're just using a WMV extension. Why? Because if you're monitoring at your edge and you see a stream of binary going and the file name for that binary is WMV, are you going to be able to tell the difference between a streaming video file and a RAR file just looking at the binary data? I don't. I'm sure there's probably somebody who can, but it wouldn't be me. Again, there's their password, and then here's the tool that passes that out. Okay? So, from what are my points here that I want to get? One, think about what they're doing here. Okay? So they got all of this in initial, right? Those really important stuff that enabled them to do everything else in under 2 hours from initial breach. Really let that sink in, okay? Secondly, look at all of this stuff they do. Now, I'm not going to read all of this, right? You guys get this. But the bottom line here is I would suspect that your existing detection systems today would not have picked up any of this. Not because it can't be detected, but because it's not what you're looking for right now. Okay? And that's the thing. What were they doing? They were using legitimate credentials. They only ended up installing 6 back doors, but yet they were on 41 different boxes. Okay? And what are our typical things? We look for malware. Right? That's how we find the scope and event. We look for malware. But in this case, looking for malware is only going to tell us a fraction of the story. The actual data that was stolen came from a box that never got a backdoor installed on it. Okay? So, few things. Key there, all of it was in less than 4 hours. All right? So then I mentioned back that first question. All right? So, of course, the other big thing is, why me? China, Russia, country X, they don't want anything to do with me. Well, they may or may not. They're definitely not attacking everybody. I am not saying they're attacking everybody. They are, however, attacking thousands and thousands of companies. Okay? And a lot of these companies are not big companies. We have figured out a lot of the reasons why different organizations have gotten hit. One, you have technology they want. All right? And they want lots of technology. I really suggest you read the 5-year plan, the China's 5-year plan. They spell out exactly what they're looking for. If you make any technology on that list, chances are good that you're a target, right? And they're going for whole industries, right? So last year, China was very interested in fracking, right, which is a technique for extracting oil from shale, right? They hit every single company that had anything to do with fracking. Every single company. Because they know how to Google too. Right? It might be that you do business with someone who is in a targeted industry. It might be that you don't have anything they want, but they use you to get into somebody they do. Okay? You do business in China. These guys are working as essentially what I would consider due diligence. Right? If you go to, say, purchase or acquire a company, what do? The lawyers go in, they check, you check their books, etc. What these guys do, they come in and harvest all your email. So they can see what you're talking about. Right? You do business with someone who does business in China. Or you're buying or selling. Right? So, are we screwed? No. All right? We are not. This is not the sky is falling. However, as I mentioned at the beginning, with that New York Times article, it's rapidly, I would suggest that regardless of whether you actually are a target, the chances are that your organization is going to be hit just as a fallout from, the next version of Flame gone bad, right, that had some code errors. I mean, that's why Stuxnet got out, right? It's because of some coding errors. It was not supposed to leave Iran, but it did because of some coding errors. So countries ramping up, right? If the U.S. is doing it, everybody's going to do it, right? So I would really suggest take another look, a different approach than maybe you are today. Examine your proxy logs. Most of this stuff is going via web. There's definitely other ways they're doing it, but far and above, its majority is going out via web. Okay? Those unusual user agents, repeated calls to default pages like iasstart.htm, right? You'll see maybe off by a little bit, right? But it'll be renamed slightly, type directory. Queries that look legitimate, right, but are just, when you actually compare it up, it's off slightly. Those can be real keys. Lateral movements in your event logs. So the cool thing is about that login activity, so remember, they came in on 0, they branched out to 3 machines, from there they went to another. Within 6 PCs, they had, the keys to the kingdom, right? That activity is trackable. If you look at your event logs, a login locally at the keyboard event is different than a login across the network. And so if you start looking for login, any baked-in admin accounts especially, those should be a regular occurrence for you to mine through and look for users logging in successfully, not unsuccessfully, but successfully within your organization, right? You can look for those now using your existing tools. Don't just dismiss those known tools, right? So you're scanning through your AV logs. You see, oh, they use pwdump. Dig a little deeper, right? Confirm that that really was a legitimate person who should be running that tool or not, right? And use tools that are able to handle Unicode. We are in a global planet. Not everybody speaks English. Questions? Sir?
2FA would have really slowed this down, wouldn't it?
2FA?
Two-factor authentication.
This particular? Yes. They have tools for bypassing two-factor.
And in the case of EPO admin, that's a service account. Can
Yes.
you GPO restrict that so it couldn't be used to log in?
That's a good question. I actually don't know the answer to that one. That's a good. Can you? All right. Yeah.
So
There you go.
if that service doesn't have to run and have login authentication, you could still have it run as service credentials, but they couldn't use it.
But here's the thing, right? And I'm all about prevention, don't get me wrong. But here's the bottom line. These guys will do whatever it takes. We just saw the simplest run because it worked, right?
Mhm.
They have tools like Pass the Hash that can bypass two-factor set. In this case, they realized EPO admin, they would have tried logging in. It didn't work. They just simply gone to another account. I can't think of a single instance of these logs where they've not found some sort of local admin that they could use within 6 computers. Right? And again, what I really recommend is focus on, not that you don't want to do logical things to prevent, right? But I would really stress that you need to think about how do you detect them quickly, right? Because all it takes is one gap around, right? We are never going to get all your users to not click on a spearfish, right? That's why they keep getting back in, right? And so they get in and they'll move around in that 2 to 4 hours, right?
So one other thing I don't know, did somebody else have something? I don't have to be the only one talking.
It's all good. I'm just running.
So you can
I want to
set
get the
up
next speaker.
SMS or SCCM so that your